I've been wanting to do a semi-autonomous camera dolly for video work and photography work for quite some time. So I've got a whole heap of stepper motors and other paraphernalia all laid out here. So what I intend to do over the next few episodes is to develop a 3-tier semi-autonomous camera dolly system using Arduinos, and hopefully in the 4th iteration of that, or the final stage of that, finish off with a Raspberry Pi, Bluetooth and Wi-Fi controller to control the entire 3-axis camera dolly remotely. So I started playing around with these stepper motor kits that you can get from places like JCar, and they're fairly easy to find online as well. And they work reasonably well with an Arduino, but they've got some limitations regarding their torque, and they definitely have some limitations regarding their speed. And the reason for that is that they are not a 48-step or a 36-step or even a 200-step stepper motor. They're geared, and they're geared to 2048 or 4096 actual steps. So before I get into too much of the hardware and what I've tried so far and what works, what doesn't work, and where I'm going next, let me take you through what I'm actually doing. So it is a 3-stage or a 3-tier autonomous camera dolly, but each section can work independently. So if you think about a plate, a rotating plate, that would be the panning mechanism, and that will be controllable by itself. Then that panning mechanism can attach to a long skateboard looking device, and that can operate by itself or with the panning mechanism on top. And then finally, with a tilting mechanism attached to the panning mechanism, I can have a longitudinal motion, I can have panning, and I can have tilting, all happening at the same time, independently controllable. So that's the idea, that's the objective, that's where I'm headed. So I'm working on the first part, which is the middle section, the panning head. So if you take a look at a plate like this one, and I've just got some of these little sliding wheels from the local hardware store. These are just for sliding drawers and sliding doors and other bits and pieces, and they're around about $10 to $12 each. But they've got about a 20 kilogram load rating, so there's no issues with the amount of weight that I want to put on top of this. So the idea would be, this would attach to a stepper motor and have some sort of base underneath it, and I can attach my Arduino with my little stepper motor controller, hook it up like that. I can actually get a little rotating plate like that to be able to do my panning. And this is just set up to do a simple example. There are limitations to these little stepper motors. 3 RPM is the maximum that you'll get out of them because of the gearing. And they are unipolar, only go in one direction unless you modify your setup and make them go backwards and forwards. And that's great. And they will take a load, but not a significant load. And I am actually thinking that my panning head will be potentially half a kilo, maybe even a kilogram, and I want to put something like a 1DX with a 70 to 200 on it. I don't want limitations. I want to be able to put whatever I want on top of this thing. So that means that I need a lot more power. Alright, so we've got our little stepper motor here, and it comes with a driver board, and these can be picked up for anywhere between $7 and $10. And for simplistic purposes or low torque or low weight purposes, that would actually work. But like I said, I want to put a lot more on this. So I won't be using one of those. And instead, let's put that to the side. I'll actually be using something along the lines of a Nema 17 stepper motor. So as an example, this is a Nema 17 stepper motor, significantly larger than its little friend here. Now when it comes to stepper motors, they come in a series of resolutions and torques, and this is a 0.68 amp stepper motor, so it's a lower torque version, but that is fine for this purpose. And this is a 200 step one. This is exactly what you would find in a CNC machine, a small one, or definitely a 3D printer. Have a look at a good 3D printer, you'll find 3 or 4 of these in there. So I can get 200 steps. So what does 200 steps mean? Well, if you have a look at a clock face and you picture 12 hours of the clock, well, that's 12 separate steps. But if you can think of telling the stepper motor to take a single step, it's a large, clunky step. That's not smooth for video or photo work. So what you actually need is more steps. Well, this is 200 steps. So picture that clock face chopped up into 200 separate slices. Each one of those is a step, and that is smoother. But for video work, especially long-term photography work, intervalometer kind of work, that's not smooth enough. So I won't be using one of those as it stands there. What I will be using is one of these. Now this is a Nema 17 stepper motor with a 27:1 gearbox on top. That means I actually have 5,400 steps, and no matter how you swing that one, it's smooth. I can take this, I can do a full rotation in about 15 seconds, or hopefully I can slow this down enough to be able to do a full rotation in something like 15 minutes. So I have a lot of ability, a lot of power there to be able to play with. How does this work? Well, here is your Nema 17 with the gearbox. This is a one of these stepper motor driver controller, and I've actually found those to be quite good. They can drive a stepper motor up to 2 amps, which is more than enough for this, or they can drive 2 DC motors. So good little stepper motor controller there, and the advantage of this is it has a 5-volt regulator on it, so if I am using an Arduino as well, I can run the Arduino from the power that I give the stepper motor controller board. Alright, so in this example here, if I actually feed this with 7 volts, and I'll be using a 9-volt battery as my power supply for every single tier. So if I actually set this up, and we'll leave it at 7.2 volts there, because these boards will take anything from 5 through to 30 volts, so you've got a large choice of power supply, and it'll still give a nice 5 volts through to the Arduino for the microcontroller. So if we take a look at the standard code that comes with the Arduino libraries, it's the Stepper 1 Revolution library, the example. And if we take a look at that now, you'll see that it's got the pins that you actually need to be able to connect your stepper to, so pins 8, 9, 10 and 11 on the Arduino. It says to set the speed at 60 RPM. In this example, I don't have a 200 stepper motor. Because of the 27:1 gearing, it's actually a 5,400 stepper motor, so I need to make a couple of changes in here. So first things first, steps per revolution is not 200, it is 5,400. And the pin out, I've used the default pin out. Because of the gearing, I can't use 60 RPM. The motor inside will be turning at 60 RPM, but everything is configured to work with the 27:1 gear ratio, so I need to reduce this significantly. Top speed for this motor is around 5 RPM. So I'll just set it to 5. There's 5 RPM, and pretty much everything as per the example can remain the same. Half a second delay, go in 1 revolution, do 1 full revolution, wait half a second, do the other revolution in reverse. The board has received the data, and as you can see, and probably hear, the stepper motor is doing 1 full revolution, waiting half a second, and then returning that revolution. Now that is doing 5,400 tiny little steps each single revolution, so I can get some very, very fine control out of that. And what I actually need to do is to make it go a lot slower for most of the purposes in this 3-tier semi-autonomous camera dolly system. Okay, so from this point to finish off the mid-tier, I realistically just need to finish making some form of enclosure. The stepper motor and controlling methodology, all of the controller board and other bits and pieces will go inside the enclosure, and you'll have something along the lines of this sitting on top, where you can mount the top tier, the tilting tier, or a camera direct, or use it as a product rotation display. So yep, I'll finish all of that off in the next episode, and then start working on the pan tilt and the skateboard, the linear motion controlling part, and we'll go from there. So hopefully you'll join me again in a week's time. So thanks very much for joining me and watching the show. Subscribers are always welcome, so feel free to subscribe, that would be great. And I hope you'll join me again next week.